Now, in the last session, we were trying to see how is that we can automate the process of creating an image where we were using a file called Docker file, in which if you specify the instructions on what you have to do, the Docker will use all the instructions line by line that is given in the Docker file, using which it used to first create a temporary container, and inside that temporary container, whatever the commands or the instructions that we have given in the Docker file, it used to run everything one by one, and then from that it used to create or build the image automatically, and then we used to name that particular image. So that is how, if I want to create any image, we will be creating our own image, right? Or the many things is, the advantage of creating our own image is, rather than we keep installing everything, we can pretty much use this image which will be having all the specific application or configuration which is available. In fact, in the same way, when we are going into the organization, now in Docker, we almost have an image for each and every open source tool that is available. So that is how we don't have to spend time in creating a new machine and in that machine installing a particular tool and then start to use it. So directly what we can do, we can try to create a container with a specific image in which it will be having all the specific application pre-built. Okay, so that is the advantage, where one half of the work what we will be doing in the Docker is creating container as if we need a separate environment, and from the maintenance perspective we can create our own image wherein we can put all the specific files inside it and use. If not, for doing a process, if you need a tool to be installed, rather than installing it manually, you can create a container in which you can have certain particular application that is pre-built or available with respect to an image. So that is how we will be saving time and doing automation in a better way. Okay, now to continue on the last part, if you see in the Jenkins, now the Docker file that whatever we created, right, the first thing, so all these Docker files, if needed, we can pretty much put into a particular repository again. So let's say these are the files or the Docker files which we created. Now if we want to store it somewhere, we can create a separate repository for this specifically, and we can try to store everything in it. So what I can do now, if you do not have a repository, simply you can create a specific Git repository in it, and you can see you will be having all the files. So now if you want, you can try to store this into the GitHub and you can make use of it, wherein wherever or any machine on which you want to write the Docker file, in that machine all you have to do is a git clone of this repository name, and you will be getting all the files or the Docker files into your machine, and from that machine you can create a image and try to share it, or if you want to do some changes on top of that, you can try to create a particular image out of it. So like this, what we can do is we can store these Docker files into the repository using a tool like Git. So once again, Git will also be useful in here, because we are not doing any development as such a program, but we are developing a Docker file using which we are going to automate the process of creating image, right? So that is how we can think about using the SEM concept or the Git tool even for storing these files. Okay, so the only difference now is, instead of storing these files manually, we can use or think about using a Git repository. So that is the only difference that we can have. Okay, now in the last class we were pretty much creating many images. Okay, Docker is not running, so let's first bring the Docker. Now once the Docker engine runs, so you can see now these are the list of images that is available in our Docker engine. So if you remember, we were trying to use these images which was available in the Docker's public repository, that is on the open source community. In the same way, now if we have all these images that we have created for our organization, where is that we are going to store? Because As of now, these are available in our Docker engine, correct? Now, I cannot share these images that we have created within our organization into the public repository or the open source community, because everyone will be using it. This is something specific to our organization. So that is when, for our organization or for the project that we are working, we have to create a separate Docker registry. And then if any user who is going to work, rather than referring to the specific public repository, we will be pointing particular registry that we have created it privately within the organization. So that is when, if you go back to this diagram, now first we will try to download the base image from the public registry. After that, once you have created our own images, we will be creating a separate Docker registry which will be acting as a private registry only for our organization, and in that you will be trying to push all the changes. In fact, if other user who wants to work, even they can try to pull the images from this private registry rather than working on the public registry. Because now let's say you have created an image which has all the files that we need for a QA person to work. Now if on a QA's machine, if he has installed Docker and he wants the image, he doesn't have to point to the public repository. All he has to do is map to this specific private repository, and from this he will try to pull those specific image. Now in our practicals, we were trying to use the base image which is available on the public repository. So that is why we were trying to do a pull, wherein by default it was trying to download from the public registry. But within the organization, you will be having a specific registry only within the organization. So the pull or push, whatever that you will be doing, will be only to that particular only to that specific private registry and not to the public registry. Okay, so that way, how is that we can create our own registry if needed? So that is what we are going to see as the last step. Now, since so far what is that we have seen, if you want to install any kind of application, you can try to create a container from an image which has that particular application pre-built, right? So that is how we saw we have images for Artifactory, we have images for Chef, we have images for Jenkins, we have images for Nginx. No matter what kind of application or a tool you want, you have a specific image available. In the same way, Docker also gives us an image in which there is a Docker registry already pre-installed. So that is how we don't have to spend our time in setting up a Docker registry from the scratch. What we can do is we can create a container using an image which has the Docker registry pre-installed, so that as soon as I create a container in any one of the machine, on that machine, inside that container, you will be having your private registry which can be used by all the other users. Okay, so that is how we can make use of the same image which is already available in the Docker. So that way, if you try to search on the Docker open source community, we have an image name called as registry. Okay, so there are a lot of images that is available. One of the standard ones that the Docker itself is giving is this. If needed, we can try to change it based on our requirement and we can publish it to the open source community. So all these things what you're seeing is there are specific people who have created a container, and from that they have modified some additional files and they have given it as a new image. So everything has a specific use case, but other than that, this is the image that the Docker itself is giving us, where it has the Docker registry server installed inside it. So now if we create a container using this image name, then inside that container we will be having the registry server of the Docker running privately. Getting it what I'm saying? So just like how we use different images, now we can make use of an image called registry which will be containing the Docker registry server pre-installed into it. So that is the advantage, where we don't have to install once again. So from any machine, if I create a container using this registry image, then inside that machine, on the new container that you are going to create, you will be having a registry server running inside it privately. Getting it? Did you get that? Hello? Okay. So now, in order to create such a container, we will use this command. So if you try to debug, what does it do? So if you say docker run, it will create a new container. Okay, so maybe let's try to put it as a diagram so that it will be clear. So now here, if you run first docker run, what it will do? It will try to create a container, correct? So after creating a container, what it will do? Then after creating the container, so if you say this particular name, so this, you are assigning a name to it. That is what when you say -name registry. So what I'm doing is, for this container, I'm giving a name called as registry. That is the name of the container. Okay, and to that, the last option, that whatever you are passing, will be the image that it has to use to create the container. So that way, inside it, the image whatever that you're going to put will be this particular one. Okay, so we are going to put this image name. So here we will put registry :2. Okay, so what is this? We are creating a new container by the name registry, and inside that we are going to use a image by the name called as registry :2. And in that, now you are saying -d, which means you run this as a daemonized, where I don't want to attach the container because I'm not interested to attach. The only thing is, I need a particular registry server running inside it, using which I can try to store whatever the images I want inside it. Okay, so now if you do this much, what will happen? As soon as you create a container, since in this image you don't just have certain particular files, but you actually have a registry server, that is a Docker's registry server running inside it. Okay, so inside it you have the Docker's registry server running inside it, and by default this Docker registry server will be running on a port called 5000. So this is what is going to happen. So it will create a container, and in the background it will try to put an image called registry :2, in which we will be having a particular Docker registry server pre-installed, and when that runs, it will be running under a port called as 5000 inside this registry. Now if I have to access this, I cannot directly access. So first thing what we have to do is, we have to map this to the host machine, correct? So in order to map, you have to tell what is the port number on the host machine which you want to map. So that is what you will be trying to specify it using the -p, where what I'm saying here is the 5000 port inside the container, that is this container, whatever we are having, that should be mapped to the same 5000 of your host, that is 5000 port of the host machine. So that is how, when this kind of mapping is done, now if from another machine, if you try to access this host machine :5000, you will be actually directly connecting or accessing this registry. So that is what we are trying to give it here. And in this, you are additionally passing one more option called as restart equal to always. What it means is, now whatever the application that you have inside it, you try to run it always. So make sure you are not just creating the container, but the purpose of this is to start the registry server inside it, and that will be running on a default port called 5000 on the registries, that is this container, and that has to be mapped to the same 5000 port on host. So that is how now from outside, or if I try to connect to this machine, then it will be redirected to this particular Docker registry which is running privately in this container on a particular machine. So that is how we will be creating our separate Docker registry, which is once again available in a container. Getting it? So now let's try to run this. So now you will be running this in any specific machine which you want to treat it as a Docker registry. So it is not like on your same machine. You can think of a common machine which can be accessed by everyone. Under that machine, you run this command where you have Docker installed. So what it will do, it will make sure that you are creating a new container, and in that container, you are actually trying to run a Docker registry directly. Okay. So here I will say my registry just for clarity. Okay. And now let's run this. So as of now, you can see that there is no such image called registry available in our Docker engine. So it is trying to download, and after downloading, it has created a container. So if you look at Docker PS, currently there is one container running with the name my registry, and in that it is actually started running a Docker registry server where it is running on a port called 5000, and that is what we are trying to expose it to this host machine called 5000. So now whenever I refer to this host name, okay, so now if I refer to this host name colon 5000, we will be actually connecting to the Docker registry which is running inside the container. Okay, so this is how we will be able to access it. Getting it? Okay, now we have the Docker registry running inside it, correct? So how do you try to access? Because we are not going to access the container, but we are going to access this particular container inside which whatever is the Docker registry server running. So in that, the only thing that we will be doing is we will be trying to pull some content into it or push some content from it. What is it? So when you say Docker registry, it is used only to store, right? So what is that you have to do? Either you have to take some image from that Docker registry to our machine, or from our machine, I have to push some image into it. So that is what we want to do now. So first, as of now, that Docker registry, whatever that we have, that is in this example, this particular container where we have created our own Docker registry. Now in this, there is nothing, it is empty, correct? So now in order to store something inside this registry, the first thing what we have to do is we have to create a reference inside it. Okay, and that we will be do using a command called the same Docker tag. So now if you say Docker tag and the name of the image which you want to push it to the Docker registry running inside this container, and what is the name of it. So here the syntax what you will be giving here is Docker tag, and what is the image name that we want to put it inside the Docker registry, and then where is the Docker registry available, so that we have to tell. And in this, what is the name of the image that you want to upload it as. So this is what you will be doing. So in this case, for example, now let's say we created a container or an image called as my image. So now if I want to upload or push an image called my image, which is available in my machine, to this Docker registry, then you will first create a reference. So this is not actually uploading, but just creating a reference. So what this means is, this image called my image in my machine will be mapped to the Docker registry under a different name or the same name. So that way, where is this available? So you have to specify it. Suppose if it was available in a different machine, then you will say http / the name of the machine, and in that machine, where is this running? We are actually running the registry over a port 5000, which we have mapped it to the host. So this is the name of the host what you are going to give. So here you will say 5000, and in this, what is the name of the image that you want to put it up? That is what you will be saying further. Okay, so in this, your new image, so we'll say either I can say the same name or a different name. So what it is going to do in this is, for this image on your local machine, on this particular Docker registry server, it is going to map a name called my image. So after this, if you simply do a Docker push of this, so if you simply say Docker push and the name of the image that you want to push, that is this, then automatically the reference for this is this image, right? So this will get and uploaded, or it will be pushed to the Docker registry server running under this machine. Okay, so that is how, before you try to push something, you have to specifically try to create a tag name or a reference to it. Okay, so that is what we are going to do now. So in that case, first let's take an image, and for that we will create a tag reference for it. And now in our example, it is the same machine on which I have created this Docker registry also, correct? The registry server. So if I say localhost :5000, I am directly trying to connect to the container, inside the container the registry server whatever we are having. So that is what it means. Okay, now in this, so we have so many images. You can pick any image that you have created for your purpose, which you should be storing it inside the Docker registry. So in this, if you say Docker tag and the name of the image, so let's take one image. So let's say I want to take this MongoDB image. Okay, so now here I will say Docker tag, this image in my machine should be mapped to the Docker registry running under this machine in this port, and in this, what is the name of the image that you want to upload? Suppose if I want to use the same name, then I will say. So here what it does is, it will just create a reference for this image under this Docker registry with this name. Okay, and once this is done, the next command all you will do is Docker push and that specific image name under your registry. So here if I simply say Docker push this one, this has been referred to this image under your machine, right? So now automatically that will try to connect to the registry server and it will try to store that. Oh, okay, there is an error here. Okay, first let's create a proper reference. What is it saying? Okay, yeah, this is fine, because as of now, okay, before that we have to add it, right? Okay, so let's first add it. So now what I've done is I have added a reference name for this particular image that is available in my machine to an image that we are going to upload into the Docker registry running in this. And to this, now if I say docker push and specify this, then it will be trying to push it. So you can see what it is doing. It is trying to push or copy the image from my machine to the Docker registry available on this machine under this name. Okay. So like this, what you have to do is, first you create an image. After you creating an image, you create a tag reference of the image name that you have created to a name inside the Docker registry wherever is available. So in case if it is a different machine, all you will have to do is specify the name of the machine here and what is the name of the image that you want to copy or the reference as. And once that is done, next thing is, if you do a push, whatever the image that you have referred, it will be automatically pushed inside this Docker registry which is running here under this name. And if any user, let's say any other user now who wants to use this image, once again the first thing that he will do is he will do a docker pull and the name of the image. Okay, so as of now we have everything. Suppose if it is a new machine on which you do not have an image, the first thing what you will do is you will try to manually do a docker pull of that specific image from a registry which is private to us. So this is how whatever the registry which is running inside this machine on a container is private. So only within the network of our company we will be able to access this Docker registry, wherein you can see we have not tried to set it up everything from scratch. We use the same concept of the image where we try to use a pre-built image called as registry:2 from which we try to utilize the container and it is running directly inside it. So that is how we can directly create a registry server using this image through the same concept of container. And in this, all you have to do is, if you want to push something, first create a tag reference for it and then do a push of the specific image name under that registry server. Okay, and from whatever machine, if you want to use it, the users will just have to say docker pull the name of your machine under which the container on which you have the registry server running and slash what is the name of the image that you have stored inside it. Okay, so like this, any point of time on any machine you can create a Docker registry using the same container where it will be acting as a private registry only within our organization. Getting it? On how is that we will be creating our own registry server which is private. And for that, once again, I don't have to install anything. We can use a concept called the same container using an image which is specifically has a registry server pre-installed. Getting it? Others? Nagesh, Satish, Vinay, are you getting it? So any point of time when you do not need this registry server, we know that it is actually running inside a container. So if I just stop this container or delete this container, no one will be able to use that registry server at all. So simply it is a container, right? So I can go ahead and say docker stop, and if I give the name of this particular container, whatever we have created, that is my registry, then it will be not running. So because of which no one can either push anything to it or pull from it. Okay, and if you do not want it anymore, you can go ahead and do a rm where forcibly you will delete whatever is the container that you have created. Okay, so this is how on any particular machine you can create your own registry server which will be acting as a private server, so that now within the organization, if you want to add any specific image to it, you will use the Docker push and you will give the port number and the machine on which it is running, and then you try to pull the same way from that registry server on a machine and what image you want to download. Getting it? Now, if you look, when I'm giving an image name, in certain places I had given a name colon something else. Especially if you have noted, while creating Artifactory server, we used something like that, where I gave an image and then colon some particular version. So even in the engines, if you have noted, I had given something called latest. In this, if you see, I am using it as a registry colon some name. So what exactly is this is, now for every image that you can create different versions of the same image. Now what will happen, for example, let's take that you are creating a new image, okay, and you are giving a name to the image. Let's say I'm creating a image with the name my image. Now after some time you have modified your Docker file, and from that, once again, if you try to generate the same image, it will be overwriting the existing image, correct? So that is when what we can do is, for every image that you're creating, you can give a label or a version. So we call it as a label or a version, where using that label you can specify a particular image, because now every image that you're going to create will be of the same nature. The only thing is few changes you might have done. So that way, if the same my image, if I have created 3 times, rather than overwriting everything, you can give a label to each one of them while creating. So that is how, let's say for the first time you are creating, I can give the name like this. The second time when I build the same image, I can give a name. So this represents that the name of the image and what is the label that you are attaching. And by default, if you just give only the image name and nothing else, then it will be trying to attach a keyword or a label name called latest, which shows that this is the latest copy of this image. Okay, so that is why in few of them we can explicitly say like this, or if you know a particular label against which you have created an image, then you can call the image name using that particular label, and it will be trying to use this image only for creating a container. And if you do not give any label, by default it will be attaching it as a latest. So whatever that we created so far, okay, and for this images, if you can see, it has a label or a tag called as latest. So that is how by default we were creating a latest label of the image. Suppose if I recreate the same image once again with some different or small changes, then I can add the label or a tag with some other name through which I can identify what is the changes that I have done in it. Okay, so that way, now here when I say registry colon 2, it means maybe the registry server has been rebuilt or the image has been rebuilt for the second time, and this is the second time whatever that you have created. But if someone has already created another new image in the same way, then they might be mentioning it as colon 3 or whatever you want. But any kind of image, if you say the name of the image colon latest, whatever is the latest copy of that image, that will be considered, and we will be downloading and using that inside the container. Getting it? What exactly is this, which is nothing but the label or the version specifically to what is the copy of the image that you are storing in the registry server. Getting it? Clear so far on what is the Docker? So now if you can think, as a regular user, instead of creating new machines, quickly I can use a specific image and create a container, and I can create as many containers as we want on the same machine. And If I want, I can also use an image which contains a particular tool pre-built, so that rather than we installing it manually, using that image, we can directly create a container inside which it will be having that specific tool or application running. And in addition, if you want to create our own image, then we will be using the Docker file, using which we will be automating the steps by giving the instruction or the special instructions inside the Docker file. And as needed, we can create our own Docker registry to store all the images which is needed within the organization, which will be acting as a private Docker registry. And for that, once again, you don't have to spend time, because we can make use of an image which is available in the Docker open source community, where if you create a container using that registry server's image, inside that container you will be having the Docker registry running privately, so that you can use that within your organization. Getting it? Clear? Any questions on what is Docker? How is the use case that is happening? And now you can see how easy it is to replicate the environment, create a new container, or replicate the container, create an image out of it. Nagesh, Satish, Vinay, Hari, is that clear? Or any questions or doubts specifically on Docker? Okay, fine. So now, if you have understood, this is pretty much from Docker management to understand the essentials. Okay. Now, because you should be knowing when to create a container, how to create a container, how to replicate a container, what is the management you have to do in terms of taking care of the container, starting, stopping, and managing it, and seeing what is happening in it, what and all are the processes. And if you want, you can create an image out of it and you can share that, and for that you will be maintaining a separate Docker registry. Okay, so these are the different kind of activities that we will be doing in terms of Docker in the DevOps way. So not just like a user only to create a container, but we'll also manage the container, manage the images creation, as well as creating new containers for having certain applications and share it using exposing the port. And as needed, we will also having a separate registry server and maintain it. Okay. I didn't get. What do you mean by Docker 0? Where did you see that? I'm not sure. Can you give me the reference? Maybe I can check and let you know. Okay. Now, so what is the next one? So from the last couple of classes, what is that we were seeing? We were trying to see how is that we can create our own virtual machine whenever is needed, correct? So specifically for the developer or QA to suddenly create a new environment where they can share or do some testing without creating a new machine. You can try to use Docker to instantly create a small environment and try to work. Okay, so that is when we were trying to see the module called as containers, in which we saw how is that we can create different containers using Docker, and in that how do you manage and try to run something, and if needed we can create our own image or use an image which has a pre-installed particular application in it. So that's how we were trying to look. Now when you focus on DevOps side, it is not about only virtualization. So one of the requirement what we will be having is to take care of the complete infrastructure. So that way, the module that we are going to see now is called as configuration management. Okay. So before we understand what is the tool that we are going to use or what is configuration management, first let's try to understand how an infrastructure looks in an organization. So if you say an IT infrastructure in an organization, what and all does it contain? So basically, it is a composite of different things. It is not just only machine. So basically, if you look, it is a combination of different machines, that is in terms of hardware and some softwares inside it, and how these machines and softwares are interconnected using the network, and how is that you are going to use it using certain people, and for that who should be able to access and who should not be able to access, that you will be defining it under a process. So using a combination of all these things together is what we call it as a IT infrastructure. It's not just about machine, but how machines are there, and in that machines what and all software that you have, and how you are connecting to different machines, and who will be able to connect into it, and how they will be able to connect. So everything together is what we call as a IT infrastructure. Okay, so how is that we are going to maintain all those things, is it a question that we have. So in this, now if you take a person or a system administrator, in order to set up the infrastructure, what and all he'll have to do. Now in terms of creating the people, first he has to create different accounts whoever is joining the company, and whenever he leaves the company he has to remove the account wherever is possible, right? Like this, how many applications you will have and how many users you will be having. If they start maintaining it for everyone, it is going to be a big task. And then on whatever the OS or the operating system on all the machines that you're maintaining, you might have to keep upgrading the operating system in terms of whatever patches available or the latest libraries or a particular tool, you have to upgrade it to the latest version. So like that, you have to do many things in terms of the operating system in updating everything, right? So again, it is not just one machine, you will be having hundreds of machines, and in each one of them it is not the same task, there will be different kind of tasks which you have to do. Is that the only thing? No. When you have to maintain the infrastructure, we also have to take a backup of several data, right? It could be a data of the user's home directory, or it is the data of a particular application which you are trying to use. Like this, for different applications or for different users, you will be having different kind of data which we have to take a backup from all the machines that we are trying to take care. And also in each of the machine, if you have certain application to be installed or deployed, how is that automatically you are going to deploy on hundreds of these machines? Because if you're going to do everything manually, then it is going to take a lot of time for us to deploy a particular application or a service on all the machines that we are handling. Same way, it's not just about deploying. Each user, now he will say on his machine or whatever machine he is trying to use, there should be some specific application or a specific configuration that he has to do. Only then we will be able to use it, right? So how is that we are going to set up all the configurations on each of the machine with respect to different users? So that is when once again there will be a huge amount of tasks that we have to take care. And finally, no matter what you are doing, we almost have to make sure that we are documenting each and every step that we are doing. That is because If you want to repeat the same task, you don't have to struggle again. Or the same thing, if you are asking someone else to do, it is easier that if you have written everything in a document so that you can refer back. So that is why writing a documentation is again a big headache, because there could be many small tasks to complex tasks which you cannot just write it in a document. But unless and until you don't write, it will not be useful, because we cannot think about reusing it unless and until we don't document. So that is when it is going to be tough. So this way, now if you look what exactly is needed in taking care of the infrastructure management is all of them. And in that, if you look what is the problem that you're trying to have, the underlying problem that we are going to have here is the state of the machine. So when you say state of the machine, it is in terms of what are the different things that you are going to do. So for a user, if he goes to a machine, he needs something to be available in that. That could be a particular application, or there could be some service running, or there should be an account created in it, or you have to take a backup, anything. So that particular state is what we are trying to look. So that way, for different machines, you have to make sure the machine is in a particular state, because of which if you want to access some files or application or a service, it should be available and it should be ready to use. So that is what we call it as the state of a machine. So state of a machine depends on what is that you are trying to configure in terms of application, or creating a directory or a file, or creating an account, or starting or stopping a service. So that is what we call it as state of a machine. So how is that? We are going to maintain the state of all the machines or different machines, wherein each machine has different kind of requirement. Okay, so that is the major problem as an organization that we will be facing in maintaining the infrastructure. So in that, using the DevOps culture, we are going to introduce a concept or a process called as configuration management, where configuration management is a process using which we will be systematically handling all the changes that we need to happen in a system, wherein every time when we want to do it, automatically we will be able to maintain all the changes that is needed in the machine, is what we call it as configuration management. So if I have a machine, and that machine, if I want to configure something, we will try to systematically means you will follow an order. It is not like random. So you will try to follow a proper procedure on what you have to do manually. The same thing you will automate it, and in this process, at any specified time, it will be automating all the process that whatever we have to do manually by doing it automatically. So such a kind of process is what we call it as configuration management. Okay, so by implementing the configuration management, what are the advantages that we are going to get? So basically, by adopting this process, we will be able to implement a particular policy on what should be done and how it should be done, and what are the procedures that you have to follow. So this is how I have to do some configuration, and in this is the step that I should follow. Everything can be specified, and for this, how is that you're going to do? So you will also specify a particular technique or a tool using which we will be specifying this is how you are going to do everything. So it is not just that you take some command or step and automate. How you are going to do it? What is the step-by-step approach? And is there a policy that you want to apply on this is how you should do and this is how you should not do? Everything can be done. And finally, you are going to use a specific tool using which you will be creating or maintaining this process called configuration management. Okay, so this is what you will be implementing. Now, if you look at the advantages on why in the organization we have to adopt the process of configuration management for doing the infrastructure management, it has various advantages, like you can increase the uptime. Uptime means you can make sure the machine is always running. And second thing is you can improve the performance, and you can ensure that there is always a compliance in terms of what you need. The exact same thing is available in the machine. And you can ensure to prevent any kind of errors that is happening by doing it manually. Whereas using this, since you are going to automate and tell all the steps, we can prevent the manual errors. Suppose if I forget to do some step when I'm trying to configure a machine, it will be a problem. Whereas using the configuration management process, you will automate everything. And majorly, you will help us to reduce the time in the maintenance, as well as we will reduce the cost, because when the time is reduced, you are actually saving a lot of money because manpower is being saved. And even if you have many hundreds of machines, just one person can take care of everything. That is possible. So that is how you're going to reduce the cost as an advantage to the company. So that is why configuration management has to be adapted as part of our DevOps culture, which will help us to improve the infrastructure management, where we are going to majorly focus on how is that you are going to maintain a state of a machine. Okay, so that is what we call it as configuration management. Clear so far? What is configuration management? Okay, so now, as I said, how is that you are going to implement a configuration management process? You are going to use a specific tool. So in the market, specifically to implement the configuration management process, we have many tools. So tools like Chef, Puppet, Ansible, and Salt, all of them are available. In that, we are going to look into a tool called Ansible. So that way, if you look what exactly is a Ansible, so Ansible is a automation engine or a software using which we can try to completely automate the software configuration management, as well as whatever the deployment that you want to do, you can automate, as well as provisioning the software on this machine, what and all software you should have and how you should have. So you can try to make sure everything using Ansible, wherein Ansible is a configuration management tool. Okay, now in that, how Ansible is going to work is basically, now if you are trying to use Ansible, we generally refer it as IaaC, or we call it as infrastructure as code. So what do you mean by infrastructure by code? Now, if you have a machine and you want to define the state of the machine, so you will be defining everything using some kind of script or file, which Ansible will try to read, and based on that, it will try to maintain the machine. For example, on a machine, if I want to install Java 1.7 as an example, now that instructions, I will be trying to put it up in a file saying that on this machine, this package should be available, or this software should be available, this file should be available, this account should be available, like that. What is the state of the machine that I need? That we will be defining it in terms of a file, in which if you say a file, you are going to write some small script or some kind of code, not a programming, but simply some kind of code. So that is how whatever that you want to do or maintain the configuration of a machine, you will be referring it in terms of a code. So that is how we refer Ansible as infrastructure as a code. It is not that you are converting your infrastructure into a code, but you are defining your infrastructure in terms of a code. So that is why the configuration management tools are also called as infrastructure as code tool or infrastructure as code processes. So the advantage of now trying to compare your infrastructure as a code is that whatever that you want to define your configuration in a machine, you will define it in terms of a file. So that is how, as soon as you have a thing in a file, now if you have a file, you can easily do a versioning of it, right? Just like we saw example back, if you have Docker file, it is a file wherein you are writing something, you can always store into your SEM repository and maintain. Just like that, whether it is a project code, you can maintain. Same way, now if the configuration of your machine can be defined in a code, I can also maintain it in a version controlling system. So whenever I want, I can use it, I can do some changes on top of it, and I can store. That is the advantage of working on infrastructure as a code concept. Second thing, if you're writing it as a code, you can always use it and test it whenever you want, correct? Suppose if I have one machine, I can quickly take that code and run on my machine, and it will be tested on that machine. If I want to test it on other machine, I can simply take that same code and run, it will be tested. Same way, it can be easily repeatable. So if I want to do the same thing, suppose I have 100 machines. Out of the 100 machines, on all the 15 machines, I want to install Java 1.7. So all I can do is write one code which will say install Java 1.7, and I can take the same thing and apply it on all the 50 machines. Automatically, we can reuse the same code to install it on all the 50 machines. So that is the advantage, where if you're writing it as a code, you can try to repeat it also. Okay. Then, where can you run this Ansible as a CM tool? So regardless of whether your machine is a physical machine that you have, or you have a machine in a cloud, regardless of what kind of machine that you are having, inside the machine, if you want to do certain configuration, then you can think about using Ansible inside it. So that using Ansible, you can automate the process of configuring or defining the state of the machine, and whatever that you want inside it, everything can be configured. Okay. Now, in that, how exactly Ansible will be working? So you might think now, what is the difference between writing a script or using the Ansible code? Because in the Ansible, if I'm saying, you will be writing some code using which you will be defining the state of the machine. Pretty much it is the same thing what we are going to do by writing a script, correct? But the major difference here is, when you are writing a script, you have to define everything to it, on what it has to do, what and all conditions it has to maintain, everything has to be done. Let's say, for example, using a script, I want to make sure I have Java 1.7 installed in a machine or not. So first, the script, whatever you write, what and all you will be having in the script. So let's try to do that. So let's say if I'm writing a script, first thing is, when I'm writing a script, I need to first tell to the script, check for Java available, and in that specifically check for Java 1.7 whether it has been installed. Okay, so for this, whatever the commands I have to specify it, everything, right? It's not just saying what is the command, and based on the operating system, what exactly is the command using which you will be checking. Okay, once it is checked, then what is that I have to do? If it is not 1.7 or lesser than 1.7, we need to do a comparison again with whatever the value that you are going to get. Correct? So whatever the value that you're going to get, you need to compare and make sure whether it is the same thing as you need. And if it is not, then you will say to install Java 1.7, and once again, for installing, what is the command that you're going to use? Whether it is a CentOS machine, you have to say yum install. If it is Ubuntu machine, then you have to say apt-get. So specific to that, you have to give all the command. And it's not just this. You need to track whether these commands were completed successfully or not. So that is one. You need to keep a track of all the written status and try to write a script in such a way that it will run, and if any step fails or it is not able to run or giving an error, it will be properly displaying us. So we have to do all these things. Whereas if you use the CM tool or the configuration management tool like Ansible, you do not have to do everything, where you will just tell to the Ansible that what is your desired configuration. That's the only thing that you will tell, but you will never tell on how to do it. Unlike in the scripting, you are going to tell what it has to do and how it has to do, correct? Whereas when you are using a configuration management tool, all you will say is, hey, go ahead and install Java 1.7. That is the only thing that you will say. Whereas the CM tool itself will take care of how to achieve it, everything automatically. Okay, so that's the major advantage, where you will be saving a lot of maintenance effort and writing everything, and it can be reused on different machines also. That's the advantage. Okay, so remember, you're just going to tell on what is your desired configuration, and the CM tool itself will take care on how to achieve it. Okay, so that way. Now, when I was saying some time back, I said we will be having different kind of tools in the market like Chef, Puppet, Ansible, or Salt. In that way, why specifically we are focusing too much into Ansible? So the major reason when compared to Ansible and other tools, one first thing is the cost. So Ansible is a open source tool, and this is being given by Red Hat. Okay, so that is how when we are working, actually many of the Linux machines on which we'll be working is based on Red Hat. So since Red Hat has been taken over Ansible and it is giving us an open source software, any kind of applications that you want to maintain, there will be certain advantage specifically to run on Red Hat. So they will be having certain modifications specifically to Red Hat. So it's always easy for us to run an open source tool specifically given by Red Hat on Red Hat, right? So that way it's an open source tool completely. When compared to other tools, they are enterprise tool. You don't have to pay anything. Second thing, there is a huge overhead of setting up everything on other tools. Suppose if you're trying to set up Chef or Puppet, then you have to do lot of setups in it. Setups in the sense you have to do lot of settings, and with respect to that, lot of maintenance effort will be there. So that is when the setup procedure itself will be complicated, and as the number of machines is going to grow, everything will be huge and the complication will also be higher. And the other thing is, those tools work on a concept called as pull mechanism. What do you mean by a pull mechanism? Is the other tools like Chef and Puppet, what we have to do is, for each of the machine which you want to maintain or do the configuration using the CM tool, you have to install a separate agent or a software for that CM tool, so that you will be having one main server. From that server, you have to pass the information to the agent or the machine in which you have this specific tool running. So that is how you will be having a server, and on each of the machine you will be having the client or a small agent which will be running, which will try to connect to the server and read the information. That is what we call it as pull mechanism. So that is when it is little complicated to work on it, and it is not simple to understand. There are many learning that you need to do. So that is the major disadvantage on other tools. But comparatively, Ansible, the advantage is Ansible works on agentless concept. So when I say agentless, you don't have to install Ansible on each and every machine, or on each and every machine on which you have to do some configuration like other tools. All you have to do is just install Ansible in on any one machine, and from that machine you can try to connect to all the other machines that you want to maintain using the SSH concept. Okay, so that is how almost on every machines we will be having the SSH available. So that is why without installing Ansible on all the machines which you want to maintain, you just take one machine, in that install Ansible, and from that machine we can connect to all the other machines through SSH and maintain the configuration of it automatically. So that is what we call it as push mechanism, because from one server where you have installed, you are going to connect to other machines using SSH and push whatever the configuration details you want into it and maintain it. Okay, and majorly if you look, Ansible uses Python internally. So that way it is quite easy for us to automate the concepts of scripting. So we are not going to use the programming, but we can use a scripting model and try to do some automation, and it is easy to learn. In fact, We are not going to write the actual Python code or a Python script, but internally Ansible is going to use Python. Okay, so we will be having specific syntax for not Python but on Ansible. So that is what we need to learn, and using that, how is that we are going to set up the Ansible and how we are going to define the state or what exactly we want to configure on each of the machine. So that is the advantage why we can see Ansible is getting popular. Getting it? So now, what is the architecture of Ansible, or how does Ansible work? So if you see, basically on any of the machine where we have installed Ansible, on that machine, first we will try to write a code. So whatever the code I was talking about so far, so we will try to write a code which will define what will be the state of a machine. For example, as I said, in a machine, if I want to make sure Java 1.7 is installed, so the code, whatever you're going to write, will be having the details on what is the state of the machine. That is, you want to install Java 1.7, that is what you will say inside it. And these files in which you are going to define what is the state of that machine will be of a file type called YAML. So just like how we have a file type of XML, similarly YAML is a type of the file which we'll be using for Ansible to specify the data. Okay, then whenever we want to connect to a machine and maintain the state, you will be running Ansible. And when you run Ansible, what it will do, it will try to SSH to all the machines that you have defined under Ansible, and in each of them, whatever the specific code that you have written, it will take and go to that machine, in which what it will do first is it will try to gather all the information on that machine, and based on the information that it has gathered, as well as based on what the details you have specified on the code, if there is any discrepancy, or if whatever you have specified on the code is not available on the machine, then it will try to update the machine automatically based on what you have said. So which means, now if on this machine, let's say you have told in the code to install Java 1.7, so when it tries to connect to this machine using SSH, it will first read all the information about that machine, and it will also read whether you have Java installed in it. Suppose if Java is not installed and that is what you have specified here, then it will update the node automatically by installing the Java 1.7. Suppose if it is already available, then there is nothing it has to do. So that is how it will connect to the machine, gather the information, and try to compare with what you have defined in your code. So if the code what you have defined is not the same thing as you have gathered, then it will go ahead and update the machine specifically based on what you have specified in the code, which defines the state of the machine. Okay, so this is how we are going to work, where for each machine, or for a machine for a particular set of configuration, you will be defining a YAML file which will be having certain code which defines the state of the machine, using which we will be connecting to different machines using SSH, and it will compare, and based on what code you have given, it will be updating the machine automatically. And in case if the machine is already as we have expected, then it will not do anything. So only when it is finding that it is mismatching with what we have specified with what you have in the machine, then only it will update the machine. So that is how you will just tell what it has to do. How it has to do will be taken care by the machine itself. Getting it? Any questions? Okay, now let's try to understand certain environment on Ansible first for today. Okay, so that way, now if you install Ansible, there will be a configuration file called as ansible.cfg, using which we will be defining all the details about how Ansible has to work. Okay, so we have to configure the Ansible. So for that, whatever the details you want to use, you will be specifying it inside a file called ansible.cfg. But what happens is, by default, when you install Ansible, it will be creating a file called etc ansible.cfg. Okay, and in this we will be using it to store or specify all the information, and when you run Ansible, this is what it will be trying to use by default. But if needed, we can have our own configuration file and we can overwrite the default file name that is given. So that way, what is the order in which it will search is, when you actually run Ansible, the first thing it will do is, it will not go and search here. The first thing what Ansible will do is, on your machine, have you created an environment variable called ansible_config, and in case if you want to specify a different configuration file, then you can specify it under this environment variable. So that is how, for the first time when you run Ansible, the first thing it will do is, it will try to check whether there is an environment variable available. If it is available, then whatever the file you have specified, it will pick that. That is the first thing. Suppose if you have not defined a environment variable like this, then on the directory where you are currently running Ansible, so when you will connect to a machine, from some directory you will be running this command, right? So that way, what is the directory from which you are running this Ansible command? In that directory, it will search whether there is a file called ansible.cfg. So that way, now if you want to use a different Ansible CFG or the configuration file, you can put ansible.cfg in some directory and invoke the Ansible from that directory itself, so that it will check in the current directory. If it is able to find a ansible.cfg, then it will try to use this and configure based on that. Suppose if it is not also available in your current directory, then it will go to the home directory of the user as whom you have invoked Ansible, and in the home directory, if there is a file called ansible.cfg available, then it will use this. Okay, suppose even if you do not have a file under your home directory, then the last thing it will do is, it will pick up from this particular location which is default. So that is how, if you want to have a different configuration file, then you can specify it in any of these ways, so that the Ansible will always come from the beginning, and whatever is available in any one of them, it will use it. If not, finally it will come to the default location and use it. Okay, so wherever it finds the file, it will pick up the first occurrence of it. That doesn't mean that, let's say on the current directory you are having a CFG, as well as on the default location also you are having a CFG file. It will not read both of them. It will read any one which is trying to get it at the first. When it comes in this order, if it tries to find it in this location on your current directory, then it will pick up that only. Okay, so remember this. So if nothing is found, then it will be always referring to a folder called etc ansible, under that ansible.cfg. Okay, then so how do you install Ansible? Now once again, if you want to install Ansible, it is specific to an operating system where we have to install it. Okay, so maybe I'll try to talk about this in the tomorrow session, so that it will be easy in one way to cover it up everything. Okay, so I'll stop.